Hello everyone. So this is our first tutorial of the semester and I hope you all can hear me. Now what I'm going to do is just do some examples and hopefully those examples will clarify the concepts further. And in these examples you will get to see all the concepts, most of the concepts, or hopefully all of them, which we have learned in the class. So here's the first one. And I'm going to do all the work today live so that you can see it happening in front of your eyes. Now, the first example is that you are given a system of equations, 2x1 plus x2 plus 3x3 equals to 1. This is the first equation. Second equation is 4x1 plus 3x2 plus 5x3 equals to 1. And the last equation is 6x1 plus 5x2 plus 5x3 equals to -3. Now, so far we are only dealing with square systems. So we have 3 variables here and 3 equations. So all the examples today will stick to these kind of problems. Now I'm going to do it using the matrices, the Gauss elimination method. So first we write the augmented matrix associated with the system. So all you do is collect the coefficients in the equation. So you're essentially just copying the equations, leaving out the variables. So that was the first row corresponding to first equation. This is the second row, which corresponds to the second equation. And this is the third. Now, what we need to do is start with this. This is our first element, the pivot, and make everything below it 0. That's the only goal which we have in the first step. So how you can do it? Multiply the first equation by -2 and add it to the second. And if I multiply the first equation with -3 and add it to third, that will bring out zeros below the first two. So let's just do that. So since we are not adding anything to the first row, that remains the same. Over here, this is a 2. I get a 0. -2, because I'm multiplying this with -2, adding it to 3. -2 plus 3, I get a 1. And -6 plus 5, I get a -1. Then -2 plus 1, I get a -1. In the third row, I get 0 here by construction, and here I multiplied with -3, added to 5 to get a 2. Then -9 plus 5 gives me a -4, and -3 plus -3 gives me a -6. Now I take this to be pivot and I want to bring 0 over here. So I need to do is multiply by -2 and add it to the equation below it. These guys just get repeated. This row is also not being touched now. I get a 0 here, 0 here, -2 into -1, I get a 2, so I get a -2. And -2 into -1, I get a 2. 2 added to -6 gives me a -4. So at this point, I have got a triangular system. So I can do the back substitutions now. The first equation gives me, the last equation, let's say, gives me -2x3 equals -4, which implies x3 is 2. Then I write this equation, x2 minus x3 is equal to -1, and for x3 I put a -2. This gives me that x2 is equal to 1. Now I put this back into the last equation which is left, reading off from here in this matrix. So the equation is 2x1 plus x2 plus 3x3 is equal to 1. So I get a 2x1 plus 1 plus 6 is equal to 1. So this easily gives me x1 is equal to 3. So these are now my solution.
-3 नहीं होगा.
Say again.
-3 नहीं होगा.
कौन सा?
x1 -3.
Thank you. So I'm doing all of these live. So be very careful that I'm doing it correctly. Now, so this, we have got our solution. But if you look at this matrix, this is not in echelon form. Let's put it in echelon form. What is going to give us is just not much. It's just that we will be able to do the back substitution once it is in echelon form in a much more easier way. So let me try to select it. I hope there's not much problem. Now you know that in the echelon form, all you need is the first element after the zeros to be 1. So that means I can multiply the first row by 1 by 2. That will bring a 1 here. So multiply this by 1 by 2 and multiply this by -1 by 2. This will put it in the echelon form. So when I do that, I get 1 half, 3 half, half. This row I didn't need to do anything. 0, 0, 1, and 2. So now I can again start constructing my solution, and this time is just, you can just read it off much easier. So x3 is directly 2. Now you put it over here, you get x2, you have a -2 and -1 on the other side, you bring it over here, you can read it off that x2 is 1, and x1 plus half into 1 plus 3 by 2 into 2 is equal to half. So halves go away and x1 gives me -3 as I had gotten before. So that's the only point. Not much difference between having the perfect echelon form or if you have non-unitary, non-one on the leading non-zero elements. Now the other thing which we talked about
Sir,
was, yeah,
सर ये मुझे बता दें कि ये जो आपने अभी एचेलॉन फॉर्म में कन्वर्ट करके आंसर निकाला है तो ये आपका गॉस जॉर्डन मेथड है या फिर गॉस एलिमिनेशन मेथड ही है ये
this is still Gauss elimination. Gauss Jordan is what I'm going to do now. It's just you do this back substitution using elementary operation. So let's do the Gauss Jordan. Or as I was saying that we have talked about the reduced echelon form. So let's put this matrix in the reduced echelon form. Now let me select it again. So this is your matrix, and you start with the first row is in the form which you want, that the first non-zero element is 1 and everything above and below is 0. So this is true for echelon form and reduced echelon form, and this is fine over here. This guy, we want everything above it to be 0 as well. And you should start from the left, then you will not disturb anything to the left of the element which you have chosen, because everything over here is 0. So I take this row, multiply it by -half and add above.
Sir, can you please repeat?
Because I want to bring a 0 up there. The reduced echelon form is that in the leading non-zero element, in each row, everything in that column, everything should be 0 except that element. So you take this and make things below it 0. They will already be 0 if you are in the echelon form. Now you want to make things above it 0 as well. That will put it in the reduced echelon form. So this column remains like that, and since I'm not doing anything to this guy, this also remains like that. So -half plus half gives me a 0. -1 into -half gives me a half. I add it to 3 halves. I get 4 halves, which is a 2. -1 into -half gives me a plus half. I add it to half. I get a 1. Now I take this guy. This is also in its row, the first non-zero element. So I need to make things above it 0. So I just add this row above. That will make this entry in its column 0, but I need to make this entry 0 as well. So next I take this row, multiply by -2 and add to the first row. This row remains same. This is just a 0, remains same. This is, I'm multiplying this by 0, adding above, nothing happens. When I add this up there, I get a 0 here. Add this up there, 2 plus minus 1 gives me a 1. Now this remains 1, this remains 0. I multiply it by minus 2 and add up over there. I got a 0. This is what I wanted. This is why I multiplied by minus 2. Now I multiply it by minus 2, I get a minus 4. Add it to 1, I get a minus 3. And since it's in reduced echelon, now this is in reduced echelon form. Wait, 1 second. And the whole point is that I was doing back substitution. Reduced echelon form does the final step of back substitution. And now the solution is in front of you. X3 is 2, X2 is 1, and X1 is minus 3. That's what we had found. So bringing it into reduced echelon form is equivalent to back substitution, and you have the final solution in front of you. Yeah, what was the question? There was a question.
It's clear now.
Okay. Now let me.
Excuse me, sir.
जी बोले?
सर आपने पहले उसमें आपने क्लास में पढ़ाया था कि आप नीचे वाले रोज को जीरो
That was echelon form. That was echelon form. ये हमने ऊपर किया ना, नीचे वाले यहाँ पे हमने नीचे वालों को जीरो किया, ये यहाँ तक ये echelon form है. This is fine as well, मगर इसके बाद आपको back substitution थोड़ा इक्वेशन से काम करना पड़ेगा. आपको ये back substitutions के स्टेप करने पड़ेंगे. यही back substitution के steps you can do using row operations. When you do that, you bring it into reduced echelon form, where you make things above 0 as well.
Okay, sir. Thank you, sir.
अब मुझे let me do a little bit slightly more complicated example. So this time I'm not writing the equation, but giving you a matrix directly. And I have 4 variables and 4 equations. Zero, 2, 3, -1, -1, 2, 3, 2, 1, 1, 5. 3, 6, -1, -1, 4. So what I'm going to do, again, pick this. If this starts getting boring for you, that only means that you have understood the method. Good for you. So take this as pivot and make everything below it 0.
सर
जी
हर दफ़ा ये पहले इसको echelon कहते हैं गॉस एलिमिनेशन मेथड से सॉल्व करना है, फिर को क्या कहते हैं echelon फॉर्म में कन्वर्ट करना है, फिर उसको reduced echelon फॉर्म में कन्वर्ट करना है, हर दफ़ा करना है.
हर दफा का मतलब नहीं है. You should never, I mean, now you are in university, you shouldn't think about that what I have to do. What you have to do is about what is your problem. So if your problem is to find a solution, then you can go to the echelon form and do the back substitution. If your problem is like someone says like I have to write a program where my final matrix should tell me the solutions, or someone explicitly asks you that do the back substitution using row operations, then you can do it. You can bring it to reduced echelon form. So I mean, it's about what you are asked to do or what you want to do. So right now, my goal is, what I'm doing right now is trying to solve the system. I have option that I bring it to the echelon form and then back substitute, or bring it to the reduced echelon form, and then the solution would be written in front of me. So let's see what do we get over here.
सर बस एक चीज़ बता दें कि हम रिड्यूस एचेलन फॉर्म तभी ला सकते हैं ना जब तक हमारे पास एचेलन फॉर्म ना हो, यानी लाइक जब हम
मतलब ये कि that's the easiest way. You can fool around, but the easiest way is go to the echelon first. This is a nice point. I think you have raised a very good point. The systematic way to go to the echelon form is reduced echelon form is that first you go to the echelon, then you can work from the left. Pick this guy. यहाँ पे जब ये echelon में पहुंच जाएगा, जो first non-zero you encounter in your second row, make everything above and above it, below the पैसे zero होंगे क्योंकि it's in echelon form. Make everything above it zero. Then go to the next row and encounter the first non-zero guy and make everything above it zero. What will happen, because it's already in echelon form, you will not be disturbing the reduced echelon form which you will be getting on the left. Those things will not get disturbed. So it's a very systematic way of going to reduced echelon form. So let's suppose we are trying to go to the reduced echelon form, but first we have to go to the echelon form. So now you know -2 इसमें ऐड किया, -3 इसमें, and another -3 over here. So what do I get? Let's do it slowly because I always make a mistake. I'm extremely bad with numbers, and unfortunately, at least in some part of linear algebra, in the beginning, you have to compute the numbers. Very soon we will not worry much about what the numbers are. So you get a 0, -2 plus 3 plus 1, -2 minus 1 minus 3, -2 minus 1 minus 3. Because I have a 0 here, so none of these guys are going to change. I can fill them up right away. Yeah, so 0 here, -3 plus 2 minus 1, -3 plus 1 minus 2, -3 plus 1 minus 2. Then 0 here, -3 plus 6, 3 here, -3 minus 1, a -4 here, and a -4 here. Now I gotta take this as pivot and bring zeros below it. So just add, and over here multiply by -3 and add. So just copy these guys, they don't change now, fixed until you reach the echelon form. And over here, just adding 0, -3 minus 2 minus 5, -3 minus 2 minus 5, 2 plus 5 gives me a 7, 0, -3 plus 3, 0, Minus 3 into minus 3 gives me a 9. 9 minus 4 gives me a 5. Yes?
सर सेकंड मैट्रिक्स जो पर्पल कलर में आपने लिखा हुआ है उसके अंदर जो लास्ट कॉलम है ना उसमें 5 4 तो नहीं होगा, एंड में 0 0 2 1 वैल्यूज होंगी, क्योंकि वो भी तो ऐड होके मतलब मल्टीप्लाई होके जनरल माइनस
नहीं नहीं, ये मैं 0 को मल्टीप्लाई कर रहा हूँ ना, तो 0 का जिससे भी मल्टीप्लाई करूँ ऐड करूंगा वो तो नहीं चेंज होंगी.
ओके ओके ओके.
So I was at, where was I? I was at this row. So minus 3 into minus 3, 9. 9 minus 4, 5. 9 minus 4, 5. And minus 3 into 2 gives me a minus 6, plus 4 gives me a minus 2. Now this guy is the pivot. इसके नीचे 0 लाना है. So just add. 1 1 1 1 0 0 1 minus 3.
inconsistent आ रहा है.
क्या आ रहा है?
सर inconsistent हो रहा है शायद.
Let's see what happens. 0 0 ये ऐड किया 0 हो गया, ऐड किया 0 हो गया. 7 में minus 2 ऐड किया, I get a 5. So as someone just said, that last equation is telling us 0 x1 plus 0 x2 plus 0 x3 plus 0 x4 is equal to 5. So 0 is equal to 5. That's a telltale sign that it's inconsistent. So no solution for this system of equations. On the other hand, if I had started with zero to so we have found inconsistency. Let me change this. Okay, let me copy it. And let me change this. This is my starting system, starting equations. And change it to, over here I put a minus 1. What will happen to the rest of the matrix? Now if I do all those substitutions, or all those row operations, I only change this number. The rest of the numbers I'll get finally exactly the same matrix. Only this guy will change, because that's the new thing in my new system. Nothing else has changed. So in these steps, because I'm adding 0, nothing happens to this. In the second step, so now you have to remember I have a minus 1 here. So when I take minus 3 into 2, I get a minus 6, and I add it to minus 1, I get a minus 7. So in this step, I have a minus 7. And when I add these two, I'm going to get a 0 here, a 0 at this point. So I'll get exactly this matrix.
सर ये वाली बात आपकी बिल्कुल भी समझ नहीं आई है जो आपने कर स्टेप के 7 कर दिया उसको। कैन यू प्लीज रिपीट?
समझ क्यों नहीं आई? वेट, मैंने ये वही सिस्टम लिया मैंने जो मेरे पास पहले था. I only changed over there was a 4. I changed it to -1. So I've changed my system. I'm now considering a new problem. पिछली problem inconsistent थी. So you can think of it as a new example. Example 3. But it's very similar to the previous one. Only this guy I changed because in the previous system I had a problem because of this number. I changed it to -1. Now I'm gonna again make it echelon. When I'll do all those, when I'll make it echelon, I'll be repeating the same row operations as before because all I'm looking at is these numbers when I make them row echelon. Whatever happens to the numbers on this side, it just happens. And since my matrix is exactly same, only this guy has been changed. And when I add these rows, I'll get exactly this matrix. Only this number will change. And how will it change? I can just look back. पहले step में अगर मैं यहाँ -1 लिख दूँ, that's the only change. Because I'm adding multiplicatives of the 0, nothing happens at this step. I still get a -1 instead of a 4. But in the next step, I'm adding -3 times 2 to this number. But this time it gives me -6 plus -1 gives me a -7, which I have written over here. And in the last step, when I went to my echelon form, I just added these rows. So when I do that this time, I get a 0. So this is my echelon form for the new system. This time the system is consistent because if you have a completely 0 row, all it's saying is that 0 is equal to 0, which is fine. But it also means that you have 3 lead variables and 1 free variable. You will have infinite number of solutions. So you can start from your last equation, which says -5 x3 -5 x4 is equal to 7. And this x4, because it's a free variable, I will take it as a free variable. So I can put it equal to any arbitrary number. Let's call it beta. So this gives me a solution. Well, let me do one more thing. Before coming here, it wasn't really an echelon form. Let me make it echelon because of this guy. So what I have to do, multiply by -1/5 to make it echelon. यहाँ पे दोनों जगह पे 1 आ गया, तो यहाँ पे -7/5. So my second equation is x3 plus x4 is equal to minus 7 over 5. And x4 is going to be a free variable, so I just call it a number beta, just for ease of my eye, so I know that I can put any number over here. So my solution is x4 is equal to beta, any arbitrary number. And x3 is minus beta minus 7 by 5. I go one equation above, my equation reads x2 minus 3x3. So for x3 I put minus beta minus 7 over 5 and minus 3x4, x4 is beta, is equal to 2. So this gives me x2 plus 3 beta plus 21 over 5 minus 3 beta equals to 2. So these betas cancel, and x2 is just minus 5, 10 and 21, 11 over 5, minus 11 over 5. Similarly, you can find from this equation x1 plus x2, x2 is minus 11 over 5 plus x3, which is, which is minus beta minus 7 over 5 plus x4, which is beta, is equal to 0. So betas again cancel, and x1 is equal to 11 and 7, 18 over 5. Kindly check if there is something wrong. Yeah, 18 over 5. So I have got my solution. x1 is fixed, x2 is fixed in this system, but x3 and x4 are not fixed. There's a relation between x4 and x3. You can pick any value for x4, beta is any real number, and then you can get an x3, which will solve the system. So you have complete solution. The same thing, so this back substitution, it was a little bit complicated because there was a free variable. So let's see how the reduced echelon form or Gauss-Jordan works, how well it works in this case. So instead of doing back substitution by hand the way I just did, this time I'm gonna take this echelon form of the matrix and make it reduced echelon. Any question?
सर आज कितने एग्जांपल्स करेंगे? टोटल कितने एग्जांपल्स आपने प्लान किए?
I will 40 minutes हुए हैं. I plan के 1 hour 15 minutes, क्योंकि ये जो है ना complete example, ये बस ये last है. इसके बाद I'm just gonna do some small, just some conceptual examples. So after this one, I'm just gonna do some conceptual things, conceptual problems, easy ones. But this one like demonstrates an important point. कि जो last हमने reduced echelon form निकाली थी, that was for a triangular matrix. This is not triangular. This is echelon. This is a proper echelon, which you cannot call triangular. So I'm just going to check that how this back substitution through Gauss-Jordan works in this case. So as I told you, start from the second row, pick up your first non-zero element and make things above it zero. So हमने -1 से मल्टीप्लाई करके ऊपर डालना है. So
सर एक चीज बताएं कि जब हम रिड्यूस echelon फॉर्म में आते हैं तो वही गॉस जॉर्डन मेथड होता है ना.
reduced echelon form में लाना ही, this is called the Gauss-Jordan. So I multiply with -1 and add to the above row. And see what happens. So -1 plus 1, 0. 3 plus 1, 4. 3 plus 1, 4. -2 plus 0, -2. Now I move to the next row over here. Take this guy and make things above it 0. So what I need is 3 times this added above and -4 times this added above. So when I add -1, 3 into -3, 3 plus -3, I get a 0. Well, let me copy it because then we all get confused. So let's just quickly copy it. So 3 plus 3, these all numbers are going to change. But I have copied the matrix above, so I will be able to read from there. So 3 plus 3, 3 minus 3, 0. 3 minus 3, 0. And minus 21 over 5 plus 2, which gives me a minus 11 over 5. And then minus 4 plus 4, 0. Minus 4 plus 4, 0. Minus 28 over 5 minus plus 28 over 5 plus 2. So that gives me an 18 over 5. So you have got your reduced echelon. Because that was, it fulfills. This is fine if you have a 1 over here. All it wanted was that the first one in any row you encounter, things above it and below it should be 0. Even if there was nothing 0 up over here, that would have been fine. But by chance, there's a 0 over there. And now you can read the solution. But since you have to have one free, so this is a free variable because it's not lead. It's not the one which shows up after a bunch of zeros. So you call it some free variable. X4 is equal to beta. And since it's reduced, you can directly read off the rest. Minus 7 over 5 minus beta by taking this to the other side. And the other ones are written up there. Which is what we had got before. Any question? This one. So let me pick a very easy example. So you are given this. This is your system. Beta is some number which I haven't fixed. Now, first question I ask, can this system ever be inconsistent? How do I know? So let me write this question over here. Can this be inconsistent for any value of beta? I don't need to do any calculation. I can just use some of my knowledge and some easy logic to conclude to get to the answer of this question. So does anyone want to take a shot? Can this be inconsistent for any value of beta?
Yes, sir, simple है. बीटा को 0 कर देंगे तो हो जाएगा इनका.
बीटा को 0 कर दे तो inconsistent हो जाएगा. क्यों inconsistent?
0 के अलावा कोई और वैल्यू होगी तो inconsistent.
नहीं.
Sir, this can never be. Sorry.
This can never be inconsistent. Why?
Yes, sir. वो असल में उसका जो राइट साइड पे जो सर वो है वैल्यू 0 है. तो अगर कोई राइट साइड पे कोई नंबर हो तो इसके लिए inconsistent.
So if I put beta is 0 अगर हो, the last equation is saying minus x1 plus x2 is 0. There's nothing is wrong with that. You can easily solve that equation. So you have to go to the echelon form to check the inconsistency. The sign was that in the echelon form, you will find a row of all zeros followed by one single one. This exact form is the only possibility when you get inconsistency. But over here, you have 0 here at this corner. So no matter how what you add, and they are all zeros over here. So if I go to the echelon form, I will be adding some multiples of these rows to the last row, but none of that is going to change this 0 back over here. So I will never going to produce any number over here, and I will not have a 1 in this. So even if I get a bunch of zeros, the last one will always be 0. So I will always have consistent solution, consistent system, and I will always have zeros no matter what the beta is. We can ask another question. For what value of beta you have infinite solutions, infinite number of solutions. For that, I just simply need to quickly solve it. It's a 3 by 3. With this method, it's actually kind of very easy to do that. All you need is -2 and just a simple addition. 1, 2, 1, 0. -2 plus 2, 0. -4 plus 5, 1. -2 plus 3, 1. -2 plus 0, -2. Sorry, 0. And when I add 2 plus 1, 3, beta plus 1, and 0. And now just multiply this by -3 and add. You're going to get a 0 here. -3 plus 1 gives me +2, beta plus 2.
सर ये 0 कैसे आया?
0 भी -3 से मल्टीप्लाई किया ना इसको, यहाँ 3 था,
अच्छा यहाँ 3, आप यहीं पे चेंज करना,
मैंने डायरेक्टली चेंज कर दिया. So now you know that if I take beta, to have infinite number of solutions, I have to have a free variable. If I don't have a 0 here, this will be, x3 will be one of the lead variables. x2 is also a lead variable, x1 is also a lead variable. So I will have no free variable. If I put a 0 here, then x3 will become a free variable and I will have infinite number of solutions. So only if you get, in a square system, if you get a completely 0 line, then you get infinite number of solutions. So I have to have beta is equal to -3, 2, then last row is 0, 0, 0, 0. And that makes x3 a free variable. So this, for this value of beta, you have infinite number of solutions.
सर यानी अगर हमारे पास एक भी वेरिएबल फ्री हो जाए तो हमारे पास इनफिनिट सॉल्यूशंस हैं.
किसकी वैल्यू 3 हो जाए?
एक भी कोई भी वेरिएबल जो है हमारा वो फ्री हो जाए.
हाँ बिल्कुल, अगर कोई फ्री हो जाए तो इसका मतलब है कि you can give it any value and then you have infinite number of solutions. Let me do just some, now not the actual solving, but just so let me write some just for conceptual understanding. Let me write a matrix which is already in reduced echelon form, and I'm going to ask you that what is the solution. So example, I guess 5. So I'm already writing the system in reduced echelon form, and this is what I get. Now think about it for a second and tell me what is the solution for x1, x2 and x3.
Already given there.
Hmm?
x1 is equal to -2, x2 is equal to 5, x3 is equal to 3.
Yeah, it's already written in front of you. Don't really need to do any work. Let me write another reduced echelon matrix. So let me just write the answer if someone is confused. x1, there's nothing over here, so it's just -2. x2 is 5. x3 is 3. Reduced echelon form is the simplest form of equations. Simplest form you can get. So example 6. Again, I'm giving you a matrix in reduced echelon form. This time it's 1, 4, 0, 0, 0, 1, 2, 3, 0, 0, 0, 0. x1, x2 and x3. What are their values?
x3 तो 3 हो गया.
x3 तो 3 हो गया क्योंकि वो सामने लिखा हुआ है. Is x2 lead
x2 is a
variable
free
or a
variable.
free variable?
Free variable. It's free variable.
x2 is free variable because it's not appearing as lead variable in a row. So x2 is any number beta.
So
And this
x1 is
you cannot make this
x1 is
first equation any simpler. So x1,
xb minus 2 minus beta.
yeah, x1 is not 2 minus beta. You have a 4. 4 times x2. 2 minus 4 beta.
Yeah.
Right? So इसके भी infinite solution.
हाँ, इसके भी infinite solutions हैं. So you get finite number for square systems. You get one specific solution, only one solution, unique solution, only if you have a strictly triangular matrix. Other than that, if you get an echelon form, then you will either have one complete 0 row for a square system, or you will have a row of zeros followed by a 1. So if you have a row of 0 followed by a 1, then you are inconsistent. If you have a completely 0 row, then you are bound to have one or more lead variables. Oh, sorry, free variables. Because this row doesn't have any information. So you have 3 variable, you have 2 informations, so 1 becomes 3. So I think we have covered all the examples. We can probably stop here unless there's any question. Say again?
Thank you, sir.
Okay, thank you.
Allah Hafiz.
Allah Hafiz.